Well, thank you. And I have old school note cards. My kids make fun of me for this. They're like, why aren't you just using your iPhone? But it works for me, hopefully. First of all, you may notice we have one last panelist here, Steve Circa, the North America head of the Alliance to End Plastic Waste, was stuck in Florida due to his flight getting canceled from the hurricane. So I think, that's bad news, but the good news is it gives the rest of the panel 25% more time to talk about a topic that I think is really dear to all of them. So again, my name is Jean Vincent. I'm the head of Research Development and Innovation at Avonic for the Division Specialty Additives, and I'm located in our innovation hub in Allentown, which is just 4 to 5 short hours east of here, so it was a nice drive. And I'm really excited to be here to moderate this panel discussion because this is a topic that's highly relevant and very dear to me, circular economy. So the degree to which economic growth is dependent on the Earth's resources, I think, has reached a level that's unsustainable, and it's at a tipping point. I think we all feel it. The circular economy model aims to keep products and raw materials in circulation by promoting reuse, recycling, and remanufacturing. We must rethink our production technologies, our policies, and even honestly, our behavior to transition from a linear to a circular economy. It's really a great responsibility, and I think our future really depends on it. So in this panel discussion, we're going to be touching on several aspects of circularity, including technical challenges and the potential of innovation. I think this is one of the biggest levers, new business models, and even a little bit about the role of policy. So as we only have a short time, I want to get to the panelists already. I'm going to ask them to all introduce themselves and maybe give a short statement about how circular economy is a topic that's very important to them. So maybe we'll start right here with Melissa.
Hi everyone, my name's Dr. Melissa Billick. I am a professor in civil and environmental engineering, and I also co-direct the Mascaro Center for Sustainable Innovation with my colleague, Gina Kowalczyk. And I'm also the executive director of the Covestro Circular Economy Program. And one of the reasons why I'm here today is to really talk about the importance of thinking about the next generation of scientists and engineers and the program that we developed and launched in the fall with our partners, Covestro.
Next, John.
So I'm John Thayer. I'm a 25-year resident of Pittsburgh. I work with Nova Chemicals, and I lead our sales, marketing, and sustainability efforts. For those of you that don't know, Nova Chemicals is also owned by Mubadala, who is one of the UAE sovereign wealth funds, and a number of the UAE companies, Mubadala companies represented here as well. So I've also had the opportunity to work across a number of industry associations over the years, working with the American Chemistry Council, most recently as the chair of the plastics division. And so really excited to talk about this topic today.
And Håkan Johnson, to beat John, I'm 30-year resident of Pittsburgh. Not here originally. So I am the president and chairman of Covestro LLC, which is the U.S. legal entity of Covestro AG, our parent in Germany, a chemical company. And we are one of the world leaders in polymers and performance plastics. So our connection to circular economy, to sustainability, you heard Melissa say we are active here in the community. We also, beyond that as well, right? We have made a full commitment to become circular, so fully circular. We also made commitment to be climate neutral by 2035, which is quite a commitment for a company of our profile. Also very happy to be, I should say that too, just like John, I'm also active in industry organizations like American Chemistry Council, where I presently chair the Board Sustainability Committee. Very happy to be here and looking forward to the discussion.
Thanks a lot, guys. I think we definitely have the right people on the panel. I know just watching the other panel discussions, I was wishing that I could ask questions, so I'm excited to be able to sit here and actually be able to be in the driver's seat and ask the questions. So the first one, and John, I'll ask you it in a bit here, but There's a quote that I read somewhere which I kind of like. I'm not sure who said it first, but that the Stone Age didn't end because they ran out of stones. And so we won't end the linear economy just when we run out of fossil fuels. I think we all know we need to get there a little bit quicker. But it's not just about making a linear economy circular. It's about doing it while you grow. So doing it while you also have economic growth, I think, is difficult. So the question that I'd like to ask, John, and please, the others as well, I'd just like to mention, feel free to pipe in and speak up whenever you have something to say. We'll keep it real informal here. How can the circular economy contribute towards decoupling economic growth from those finite resources, the stones or the fossil fuel?
Yeah, I think it's a really good question. I like the Stone Age analogy there.
I can't take credit for it. It's not
no, but
I Googled it.
You know, when I think it's really an interesting time to be in the plastics industry. So Nova Chemicals produces polyethylene, and polyethylene is the world's most widely used plastic, and demand for polyethylene is going to continue to grow. But what is changing and what will accelerate in change is where the feedstocks come from. So we had an opportunity to listen to Hillary on the first panel about the great investment that Shell's made in the region here, really with a renaissance of the availability of natural gas liquids and feedstocks here in North America. And so you've seen the industry really blossom and grow across the period of 2015 to today. And what's changing in the future is going to be where that feedstock comes from. So more and more, we're going to be looking for different feedstocks of recycled materials. So those will be materials that are traditionally recycled today, like PET and high-density polyethylene. But it'll also be more hard-to-recycle items like linear low-density polyethylene, like polypropylene. And as we integrate those products back into the feedstock area, we'll be using more and more of those as raw materials. So that will cut into that growth curve of virgin polymers with recycled polymers. But we still, you know, between now and 2030, 2050, we still see this great demand for plastics because essentially plastics do more with less. And so it also has a really important aspect as we look at decarbonization and energy efficiency and the ability to feed the world and things like that.
Yeah, that's really interesting, and I like what you mentioned about plastics, you know, durable goods. If you could make them durable for longer, right? So you're not necessarily making them more circular, but you're making that cycle a longer cycle, I think is important. And you also touched on a couple of things that I wanted to talk about as well, the difference between the different polymers. You know, if you're talking thermosets or if you're talking thermoplastics as well as renewable type. So maybe I would ask a follow-up question as well to maybe perhaps Dr. Johnson, you could answer this. How do you see the relative roles of the different recycling techniques?
Well, yes, maybe we just categorize them first. You have the mechanical recycling, like the old way.
Right.
And then you have what in the industry we call advanced recycling. You can call it chemical recycling, call it chemolysis. There's a few different names. And if you talk about the next 3 to 5 years, certainly mechanical recycling will continue to be very, very important. And as John, as you said, if you have well-defined streams of let's pick maybe the easiest one, if you want to call it that, PET. So the bottles you hold in your hands when you drink water, well-defined, well separated. When you recycle those, you can get back a material that can go into bottles again. It's well defined. There's other ones that are more difficult because you might not get enough of them, you might not have them pure enough. And then, of course, there's some polymers out there that is you cannot recycle with mechanical recycling because you cannot just melt them down and fuse them again, right? So it's so-called thermosets, right? And there you need something else, unless you just want to degrade the material, but that's not the idea. You want to, as much as possible, obviously, you want to bring the material back to its original value as a raw material again, right? And that's where advanced recycling chemolysis comes in, and where you then use catalyst and temperature, and then you break the material down and into its original part, so to say, right? Then those chemicals then be used, put back into the process again, right? So that is the idea. That's where we are striving to as an industry. It's going to take a little bit to go there, but that is if you want to call it that, the holy grail, right? And just maybe a little bit, I think there was earlier today we talked about the value of or importance of artificial intelligence and digitalization, high tech on getting there. And here's one place where we and others, we use quantum computing, for example. So we are working with companies like QCware and Google. How can you do that chemolysis the best possible way? So we use simulations. So we use quantum computing to do simulations on how you can get down to the molecular level. How can you get that the catalyst work the best in the most efficient way, least use of energy, and so on and so forth, right? So it's a big step from the mechanical recycling going then to the advanced recycling, because that is really high tech, where the industry will use any kind of artificial intelligence that is available. Right?
It's great, thank you. There's a lot to unpack in there, I think, of what you said. You touched all of the topics on that one. Melissa, would you like to follow up with anything on, if we stick with maybe the chemical recycling, on where you see the role of chemical versus mechanical recycling?
Sure, and I wanted to kind of also mention two other things. One of the things that we think about when we say a circular economy, I think we also have to think about the people that operate within that economy and to make sure that there's equity for those people. And I think that that is really an important part of circular economy, where it's about products and it's about innovation, but it's also about an equitable society as well. And so that's the one point I wanted to make. And also, in working with a number of different students across the university, this is something that they are really passionate about as well, so for the next generation of workers. And I also wanted to specifically talk a little bit about a National Science Foundation project that I'm the principal investigator on. So one of the programs is Growing Convergence Research. And I brought together a team of people across the U.S. from Maine, Illinois, and also in New York, and great people at Pitt as well. And one of the professors, actually Chris Wilmer in chemical engineering, is specifically thinking about how to develop blockchain to enable the circular economy. And people are working in that area. And the reason why that's super important is because really all the blockchain is like a fancy accounting system, if you will. And for circular economy to be really effective, you need to know where the material is located, the value of that material, and if you are working within that trusted network. And so again, we're looking at setting up those different blockchain technologies in order to enable circular economy.
Yeah. If I may, actually, to build on that, we have one project with the Porsche, the German car manufacturer. We use Circularize that manages that. So we and other suppliers of our materials are using exactly that, right? Because Porsche wants to know how much recycled materials in there. Is there any bio-based content or whatnot? So it's like kind of declaration on what could be in there, right? And we talked about ISO standards earlier today, and so these things can help also to validate, and it can get audited, right? So if you're selling a part to Porsche, said it's got X% of something in it, right? Of bio-based material, they can say, is that true or not, right? And again, the value chains are quite complicated too, right? And there's many. In every step in the value chain, you collate and then you collect that and put it into the blockchain, right? So it's going from e-coins to sustainability to supply chain, where it's quite extensive use in our blockchain, and then into other more, as I said, normal use, right? You wouldn't think about before, right? So.
Yeah, could I just add
Please, John,
a couple of things? So Steve Syker's not here from Alliance to End Plastic Waste, but Steve had a great career at Procter & Gamble and left Procter & Gamble to join the Alliance to End Plastic Waste, which was a really a cross-value chain initiative that's come together to really end marine debris and waste in the environment. And so while we have these great products that we produce that provide all these great benefits, they don't belong in the environment. And it's clear that we have issues globally around keeping plastics in the circular economy and out of the environment. So there's two projects specifically when we think about blockchain that I wanted to highlight. One is in Europe that Alliance is sponsoring and helping fund, which is looking at kind of identification on packaging, rigid and flexible packaging, and how that can be traced through recycling, and then that technology can be used in advanced sortation for materials that can be easily mechanically recycled or need to go to some form of advanced recycling where you go back to the core building blocks of the products. So
that's great. That's a good build. And what I'm hearing, or what I'm thinking of as I hear all of you speak, there's really two major challenges that we've talked about so far. It's the technical, how do you recycle, whether it's chemical or mechanical, and then also the value chain. How do you find the material? How do you get the material to where it needs to go? And there's so many different things that you could use to help with that, but we talked a little bit about artificial intelligence. Mm-hmm. So I wanted to ask that question, and I don't know, maybe Melissa, you as well have something to say about artificial intelligence as far as, do you see ways we could use this to enable the circular economy more? Dr. Johnson mentioned doing it for design of materials, but how about on trace and track, or on knowing where those molecules are, or leveraging to get those waste streams where they need to go?
Yeah, so one of the things that I think is important, you had mentioned that as well, is throughout Europe, in the US and throughout the world, there are environmental product declarations. And I think we are all trying to realize kind of the wealth of that knowledge within the environmental product declaration. And I think utilizing AI to kind of bring together a host of the EPDs and then apply that to circular economy strategies can be one particular approach.
Yeah.
John, did you have something to add?
I mean, I think, as we look at, back to your first question around where are these new feedstocks going to come from, we really have big gaps in the collection, sortation, and the ability to reuse these materials. Plastics made to be remade, so we can remake them over and over, but to be able to collect them. So I look forward to where artificial intelligence and other innovation will happen on that front to enable that feedstock back into to materials again. I mentioned the project in Europe. There's also a project in Canada that BASF is leading called Resi Chain, and it's the same thing. It's putting like digital watermarks on materials.
Right.
So as a brand owner, you don't see this digital watermark, so you can still have that appeal to the consumer, but it's there, and it enables that to be put in its next best place versus in the landfill, right? So
yeah, just to be a little bit, this whole environment, it's very data rich, right?
Yeah.
And it will get pretty complex fast. So if you have even a relatively simple thing is to say you have a laptop, right? You have a laptop computer made out of different kinds of materials, right? And if you start what's the best way to disassemble that, and then once you start to break it down, what are the separate materials? How pure are they? And when you start to figure out what's the best way to recycle that, it can get very complex quickly, right? And machine learning algorithms are being used to try to sort that out for us humans, because we cannot really do that in an efficient way. Right? That's still a long way to go, but you get one more example of where I would say the circular economy, it's certainly the right thing to do. It's good for the economy. It's good for a lot of other aspects too, as Melissa, you said. But it's also good. It's bringing high tech and innovation into the polymers, the plastic business as well. Right? Absolutely. Right? And you try to use the cutting edge technology of other fields, totally different fields, bring it into this arena. Right?
Yeah, and a professor once told me there's a big difference between a useful mix of chemicals and a mix of useful chemicals.
Yeah.
You know, because you can't always use what comes out of some of these recycling processes. So with that in mind, I mean, maybe we can talk a little bit about product design and our social behavior around it. Are we at the right starting point to make the economy circular? Are we making the right materials circular? Do we have the right goal in mind, or should we be looking to have a complete shift of the type of materials that we use or the design of the products that we buy?
So I can start first. I mean, I think one of the things that I've really learned over the last, say, 4 to 5 years, especially working with my colleague, Dr. Eric Beckman, is that we need to learn how to design across scales. So for example, the kind of molecular configuration that he's coming up with will end up as a product that will then be in a building, right? The Covestro may be supplied. And then at the end of the day, you'll have city planners or architects or engineers that need to take those components and disassemble them for new purposes. And so learning how to communicate across all those design scales, that to me is really the key in thinking about circular economy strategies. And it's something I think is really interesting and fascinating. And you think about this from the molecular design to the city scale, but there's all these intricacies in between as well.
Yeah, I mean, at our company with Nova, we work with customers in various specific markets, and one of those markets is food packaging. So if you walk up and down every aisle in the grocery store, there's polyethylene in every aisle in the grocery store. And so, what gets the most attention is the carry-out bag, right? That is recycled at the front of the store and things like that. But that store is filled with polyethylene. And that polyethylene is complicated. So a lot of those films that are protecting your steaks, your chicken, your hamburger, your cereal, your bread, your fruit, your whatever, I mean, there can be up to 11 layers of different plastics in that film. And so designing that film so that it's one material, not 4 or 5 materials, is really critical so that you can pull that material back and make it more easily recycled, either in a mechanical recycling environment or an advanced recycling environment. And into that design, it's also designing for shelf life of food, for transportation. So you have to look at the greenhouse gas impact of what you're delivering when you deliver food to the store, how long it's going to stay fresh on the shelf, and then how long it's going to stay fresh at home. And we can extend the life of those products through packaging, the right packaging designed for the right purpose, by magnitudes of 4, 5, 10 even. And so that has a really significant impact on food insecurity and waste. And so design is absolutely, that's where it has to start. It has to start with design.
Do you think we're focusing enough on that?
I think we're learning to focus on different measurements of success, right? And so if you define success just on cost, right? That model has to have a point of where there's cost, but other values that are assessed and have an attribution there. So we're learning, but we're not there yet. Absolutely not there yet.
Melissa was shaking your head very strongly.
Yeah,
no, we don't focus it on design enough, is what I got from.
Yeah, and I think that's one of the reasons why we were inspired to create the Circular Economy program at the University of Pittsburgh, because we know that we need to change how engineers and scientists think about design, how they're trained to think about design. There are so many complexities and different nuances that they need to consider that. That's why we think that that's a really important part of the program.
Yeah. So I got the master and a doctorate in chemical engineering. So I know I'm trained to everything can be solved with an engineering solutions, right? We're going to put enough brute force in it, we're going to fix it. I think in this case, it's important to recognize that if you design it from the beginning on the right way, that will be very helpful, right, to get to a circular economy, right? Because we don't we cannot solve everything with engineering solutions. You got to take a step back and see what is the best way to design the product, to design how to use what is the raw materials, and how do you then bring things back again. So designing along the whole value chain will be more and more important, right? Engineering won't take it. It's obviously we need engineering too. We need engineering solutions, but you need good design, well thought through design. And one issue with that is that I don't think there's enough focus on that topic, right? And I'm not alone about that, but I think that's what we need to definitely, both from academia, but then also from the company, to spend more attention to how we design things.
Yeah. Interesting topic. I think there's a lot of energy around that one. Maybe one we haven't talked about yet is entering the circular at maybe a different point. Instead of starting from a fossil fuel, if you're starting from a renewable source. So I'm interested to know, what the panel thinks about starting from renewable resources, whether bio-based as opposed to fossil fuel based that you're then recycling, so it's kind of in the cycle already. What role can bio-based raw materials provide into a circular economy? And John, maybe we can start with you.
Yeah, there's a role today, and there will continue to be, I think, a growing role for renewable products. And when you think about packaging in a broad sense, we got Emirates Global Aluminum sponsoring here today, and I came out of the paper industry before I came to Pittsburgh back in 1997, and I worked for a company called Weyerhaeuser Company, which big producer of paperboard, packaging, and lumber. And one of the most exciting things I did with them back in the mid 1990s was open up a 100% greenfield recycled paper mill, right? So it was bringing old corrugated containers. I think it was about $1 billion investment back in the day, and not many trees harvested in Iowa for paper, right? So it was a location there to bring back old corrugated containers, and I think our industry will look for those as well in the packaging plastics industry. There's a role for renewables. There's a role for reusables. There's a role for recyclables, and it's really an all of the above strategy, I think, to really win in the circular economy. And I want to make sure we're linking up when we talk about circular economy. We talked about it earlier a little bit too, but it's decarbonization and it's circularity, right? And it's that whole life cycle analysis of the products and the benefits that they provide. So.
Yeah, and life cycle analysis, it's good you bring that up, because you can start with a renewable raw material which has a higher carbon footprint because of what you had to put in to grow it than if you had started from something different. So I think that's really important to keep in mind.
Yeah, and be specific to as Hakan said, be specific to the application, right? Design it for the application. So, yeah.
Okay.
Maybe one comment on renewables and bio-based. Certainly that is important for us too. It will be important for the industry. There we have a little bit of a scale issue right now. We offer some of our products fully climate neutral, right? But it's only so much of that available today, right? Because we have proven proof of concept we can do it, right? And we can start then with something that grows or something that come out of the kitchen, right? And we can make that into the materials we've been selling for 50, 60, 80 years, right? You can make the same thing, same properties, so it works. And we have you can buy it if you would like, right? And the problem is if we would switch and the whole industry would switch tomorrow, there will not be enough renewables around to do what I just described, right? So this also, it's a scale issue. We all need to work on it. It goes along the whole value chain, right?
Right.
And we all need to work in that direction so we can make enough of those materials available. Be that through renewables, bio-based, or be that through, and when I talked about advanced recycling, we bring it after end of life, right, to bring it back into building blocks so we can use them again. So we all need to work on create those value chains so it simply will work, right? We will get there, but and everyone needs to be committed to it, and we all need to pitch in. No one can do this themselves. No company, no community, no part of industry, not even the country, right? That was also pointed out earlier this morning, right? That we're working across country borders too, right, with different restrictions. So it's a big job. We will get there, but it's going to take a lot of work.
And I would just add, we say circular economy, right? So we think about this global economy, but one of the things that I think is also interesting is to really think about it from a circular economy's perspective. So regionally, what is happening? And so in some instances, it's really important to think about water quality and water depletion. And so would a renewable or a biosource be, best produced or created in that place, or should that be in another location? So really matching up like regional supplies and regional economies with really what's prolific, I think, is an important part and an important conversation to have around circular economy. So shifting from one that's so centralized to one that's potentially more decentralized.
How do we get there, right? Europe, you have the Green Deal. China has a 5-year plan. What do we have that's going to get us all there so that we can increase the overall quota of what we recycle? It's clear we can't do it alone. Every panel discussion so far about sustainability today has been we can't go it alone. We have to partner. Is there a role for bigger involvement for policy in here to bring the players together?
Absolutely. We need to have good policy to link this all up. So if on a global basis, you look at the United Nations Environmental Assembly and global plastic treaty, right? So we've made progress just last year on that, where regions, to your point, are going to kind of define how they can contribute and enable the circular economy, and it will be different in different areas because we're at different starting points. Here domestically in North America, we are very fragmented from a collection, sortation, identification of what's recyclable and what's not. And frankly, I think it's pretty confusing to consumers at times, right? And so at the American Chemistry Council, our company's been advocating for a national framework related to recycling that would mandate recycling rates and dates, right? And so, for the first time, we're saying we want extended producer responsibility. We want recycled content mandates that are going to drive different changes in packaging formats and how we reuse materials. We want a science-based approach, that looks at the greenhouse gases and so that we're not, trading risks in the environment, and so that we're looking out for the environment in whole. And we're also looking at the state level, right, related to passing legislation that's going to enable advanced recycling. So I think 20 states today, including Pennsylvania, have passed advanced recycling, considered as manufacturing, not incineration, because you're pulling that material back and putting it into other raw materials. So anyway, that's just I think we need to do a lot more there and accelerate that aspect of it, because it's going to take, the circular economy model is so different than the old model around our traditional way we did business. And in the ability for government to play a role is really critical.
Håkan?
No, I agree. There has been steps taken lately here in this country too in that direction, right? I always say too that the carrot is better than the stick. There needs to be all kinds of there are all kinds of opportunities or possibilities, right? Where the government can get involved, right? But again, preferably with a carrot approach rather than a stick approach, right? And I think that's proven time and time again, right? I think that for the U.S. now, with the first step is set to move this country also into a place also from a regulatory or from a policy, it's about the word, from policy perspective, where maybe China and Europe have been for a little bit now, right? So I think that the first step, be it not perfect, but the first step is there, and that will also, and that is needed, right? Of all the reasons I just said before, that no one can do it alone, right? We need, everyone needs to be aligned in the same direction, going in the right direction now.
Right. Melissa, did you
Yeah, I would just add as kind of an enabler sort of question. We all are consumers as well. So to your point earlier, we are all voting every day when we purchase something. So from a consumer perspective, I think we can also really think about how we can individually enable a circular economy, and also within our spheres of influence.
Okay. So I think we're getting close to the end here. But I do have one more question, but maybe I'll leave the question for you to answer in kind of a closing statement, and we'll go down the line. But I'm a chemist, so I think about ways we can influence circularity from a molecular level. So how can I change those bonds to be recycled? How can I convert one thing to something else and make it more usable? So I think a lot about that in my team, about thermosets, about how to undo some of that chemistry. If you think wind blades, this is going to be key for, we said hydrogen and for energy, but where do they go? We have to find ways to recycle these. And I think, it was said here by the panelists that we have some technical capabilities to do it, but we need to be able to scale it. It needs to be economical. We need to be able to make money from it at some point. So there's a lot of chemical challenges ahead. So I would ask each of the panelists, what do you think are the biggest fundamental advance that we need to make, whether it's technical or whether it's social or policy that we need to make in order to really further enable a circular economy? And we'll just go down the line if that's okay, Melissa, and start with you.
I think it's all of the above. And I think I think that a key part, especially in higher education, is to think about how we're training the students, right? And so again, it's not going to be one technical solution that's going to solve a whole economic problem, right? That's not going to happen. But it's a mix of different skills that students need to learn as they come out of different programs. And so again, I think it's a mix of different ideas. But I also think there's the opportunity for true innovation within the circular economy. So whether that's either from thinking about building design, thinking about city design, or thinking about molecular design, I think that innovation can happen at all those different scales.
That's great. And the program with Covestra, I think, at Pitt really ties right into that, to teaching the next generation for us to think that way.
Exactly. Thank you.
John, your thoughts?
Yeah, I'll just reflect back over the last 3 or 4 years, and I really think the industry, the plastics industry's made a pivot, a really strong pivot around, not only talking about the benefits of the products, but our role in cleaning up the environment, our role in creating a circular economy, our role in, asking for the good regulation and good legislation that's going to enable that. And I think that we're getting a lot of momentum right now, and the thing we need to do is just double down. Is go faster, go harder, have more vulnerable discussions with legislators and things like that to accelerate what we need to do all across to the value chain. As Hakan said, and that's what's difficult. It's harder to say yes to things than it is no, and getting the value chain aligned around those things is all the way from consumers, as you point out, to ultimately to the raw material producers is more difficult. So.
I'll summarize in 3 words, right? And I kind of picked up a little bit here. So, we need creativity, we need collaboration, and we need commitment, right? If we get those 3 things right, we will be successful.
I think that's actually a great way to end. I'm going to remember those 3 C's. And this has been a great discussion. I really enjoyed doing it, and I thank you for letting me moderate it. I'd like to thank the panelists here for a very insightful discussion on circular economy.
Well done.
Thank you.
Thank you.
Great.